a quadratic. And the whole chapter 2 is about a quadratic. Quadratic, we know what they look like. After that, this is ax squared plus bx plus c with a restriction, do not let a be a 0. And I think all of us in class know, if chapter 2 is all about that, and they all look like this, which they do, why are they insisting that don't let the a, the leading coefficient, be 0? Why, when you pick up the textbook and you see it, why are they putting a restriction on you? Don't let a be 0. What would drop out if a were 0? If a were 0, there's no x squared. And that's what makes a quadratic. So they're saying, please do not let a be 0. When I picked up a math textbook in grad school, I saw these theorems, and they had restriction, 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 restriction. I thought, why all those? And then I find out it's undefined. I can't use it if I let this be that. Okay, so there's a restriction there, don't let a be 0. We know at this point, if that leading coefficient is greater than 0. Just sort of a little recap. These graph into parabolas. If the leading coefficient is positive, what are you guaranteed for the shape of the parabola? It opens up. You're guaranteed. If it opens up, you have a vertex. We mentioned this word Monday. You have a vertex, which is like a turning point. And if it opens up, you can also put a comma here. You could identify that vertex as, what other vocabulary could I use here besides calling it a vertex? I could call it, Lisa?
Turning point.
Can we get it?
Turning point.
A turning point, yeah, that's beautiful. Something else.
Absolute minimum.
Beautiful. I'm going to use the word minimum here. It is absolute. Who said that for me? Yeah. It's an absolute minimum. By the way, is it a local also?
Yes.
Is it, of course, it's a local and an absolute. Is this point higher and lower than all points close to it? Is that point lower than all points from side to side close to it in that particular locality? So it's a local, it's an absolute. Chapter 2 says, please have students call it it's both. Just call it a minimum. Now, if a is less than 0, we are guaranteed the shape parabola will be that. That's all it takes, that a value, to determine what the shape will look like. If it opens down, of course, we still have a vertex, turning point. But guys, what's another term I could use here for the vertex? Maximum. This is the maximum. And that's what we were sort of discussing on Monday. With that said, I think I also pointed out, I sure did, part 2. We discussed this, the vertex form. The form they want in chapter 2 for functions that are quadratics, they want to look like this. Now guys, this is the way your textbook has it written. I'll use what they have. They write as a times x subtract h squared plus k. Now, can someone from Monday tell me right quickly, why would they want us to take this as a quadratic? This is what most students think of as quadratic. But they want us in chapter 2 to change it to this.
To see all transformations.
Exactly, where there are some transformations taking place. It says, in this case, what? There's a horizontal shift to the right, h units, they call it h. And there's a vertical shift up, k. So they're saying the vertex then, just by mere observation, could be listed as h to the right, all right, like that, and k up. That's all they're talking about. So if I place it in that form, I can quickly know where this right here is. I'll know where this is. If a is negative, I'll know it's this type. If a is positive, lots of things to watch out for. If a is positive, it's going to be one of these types. But the vertex on both these can be discovered right here. What Lisa said, those transformations tell you where the vertex is. And it might be one opens down and one opens up. Okay. Well said there. vertex form. With that said, just take me right to where it should be. This is all gonna connect here in chapter 2. Oh, it sure is. Okay, here goes. Part 3. Sketch. This quadratic function, and I created this right quickly so it works. Negative 2x squared, subtract 7x plus 4. Now if you want to make yourself a little note there, this will be on the quiz next week. These are longer problems to do. This will be on the quiz next week, not tonight. By the way, guys, is that a quadratic? Certainly it is. A is negative 2, B is negative 7, C is 4. Again, I hope all those numbers are written down correctly. I want to know where, well, first, let me ask you. When I graph this, I'm going to graph it, sketch it. Is it going to open up or down as a parabola?
Down.
Down. If it opens down, am I talking about eventually a max or a min? If the parabola is opening down, which we think it is, will it be like this?
Yes.
Therefore, I'm talking about a max. So I know that ahead of time. So it's going to be opening down. If that parabola does not open down, I've done something wrong. And also I'm going to identify what a max on the problem. Guys, to put it in form, I need this. I need to place this in vertex form. I would prefer in step 1 to write this as y is equal to this. Just a little recap. And then complete the square in an attempt to make it look like this. To complete the square, that leading coefficient should be a 1. That's not a 1. I can make it a 1 if I divide both sides by a negative 2. I end up with y over a negative 2. Be very careful on the right-hand side. I see x squared plus 7/2 x minus 2. See if you guys see the same things. If I divide by 2. A negative 2 in fact. And change my sign. I hope you guys agree.
Mm-hmm.
Okay, step 2, trying to complete the square. That means, let's move that 2 from the right hand side over and put a blank here and get ready. This is going to be an awkward one, but it's going to work. Get ready for the completion of the square. Wow, it's getting awkward already. Now what's it going to take on that blank? We've done these so many times. You take 1/2 of this middle coefficient, 1/2 is 7/2, which is awkward, 7 over 4.
49 over 16.
There you go. Then square it. 49 over 16. Goes here. Here. Now that should, if I'm correct, should make the right hand side a nice perfect square. That's what it's all about. The guys that up here would now factor into, when I say up here, right here, that trinomial, should be a nice perfect square. If I'm correct here, it's what? X plus, help me out, 7 over what? 4? 1 squared. Nice. That's done. That's why I asked you guys to do completion of the square back in chapter 1, because I knew it's going to come up again. Here it is again. The other side requires us to put fractions together, numbers together, with a common denominator. Trying to clean this up. If I put these two together with a common denominator of 16, someone's going to have to help me. This becomes like 32. We change that to 32 over 16. That's 2. Add them up, 32 plus 49, was that 81?
Mm-hmm.
Over 16. We're down to there. Step 3, I gotta get the y by itself. Solve for y. Move that 81 over 16 over. Be very, very careful. You want to end up with, like, am I? 2, okay, x plus 7 over 4 squared, and we're moving over 81 over 16. Trying to get the y by itself.
And
What's my last step to finally get that y completely by itself?
multiply by.
Multiply everything by
-2.
-2. As I multiply everything by -2, they cancel there, of course, you get y. Right-hand side, of course, -2 there in front of this. Now, here's where you gotta be careful. That's gonna place right here. You're also multiplying that last term by -2. Well, negative times negative on the end, which will give me a positive. What's the best way to express the end term?
1/2, maybe.
It's a positive answer. But what's the best way to express it after you simplify it? I think it's 81/8.
Mm-hmm.
Is it 81/8?
Yeah.
Let's cancel 2 and 16. 80. If I were sitting where you are, and someone asked me, with all the math I know, Professor Ramsey, is this equivalent to this? I might question myself. Look how different they look. Look how different they look. But I can show they are the same, just written differently. Now, why take the time to put this in this new form? They call it the vertex form. So this is your vertex form here. Now, can anyone recall, if you have it in vertex form, Lisa, in terms of transformations, is there a horizontal shift going on? I think it's 7/4 to the left.
Mm-hmm.
So if we'll write that like this,
-7.
7/4, comma, and
81/8.
the last number is your y. That's my vertex. I'm gonna put a B there. That's my turning point. That's it. That came from this. Now, if we use the formula they have in the textbook, says h should be the x coordinate of the vertex. You say, wait, Professor, you have x plus 7/4. If you want to, you don't have to. I see a transformation. You could have written it like this. I don't think you have to. If you really want to make it look exactly like this. And you see now the h is -7/4. Now the other, and also it's a horizontal shift to the left, so it makes sense it's negative. Then a vertical shift up. That's your point, your turning point. Will play a big part here. Yes.
On Monday, you gave us a
Oh,
formula.
not yet.
Oh, okay.
Don't take the fun. I'm having fun tonight.
Okay.
Spoil it for me. I'm going there. Okay. Guys, got the vertex form, we got the vertex. Now we're supposed to graph this. We're supposed to sketch it. Now, he's telling me before I jump in and sketch it, Professor, he said, I think he had time Monday to show us a shortcut on how to find that vertex. And I'll go through what you just went through, Professor, because I know what happens with students and myself. Arithmetic will mess us up. That's why I'm being careful on the board. If I had placed the wrong number, 49/16 on that blank there, doing the arithmetic of some sort, that would have messed up the entire problem. So what I would do, and I'm going to slow down and do it right now, I'm going to do what we did on Monday. We had a shortcut. In fact, I think we came up with a formula. Guys, that formula was, and we'll just do a little quick check on the side here. We solved this. If you want to find the vertex without going through all this, the vertex is negative b over 2a for the x coordinate. Now the other coordinate is awkward. But if you're a student who likes formulas, go for it. I think it came out to be
4ac
4ac
minus b squared.
Over 4.
4ac minus b squared over
4a.
4a. That's the most awkward formula ever. The reason I don't use it, it works. You guys please use it. The reason I don't use it, I use this one. Oh, this one's easy to remember. Negative b over 2a, negative b over 2a, I can remember that. This one, you know why I get thrown off myself on this one?
Quadratic.
Yeah, it's too much like the quadratic formula.
Is there
The
a
quadratic
reason?
formula says what? B squared minus 4AC, right?
Yeah.
Yeah.
And sometimes I'll write it if I'm not watching incorrectly, because it looks so much like the quadratic formula. I'm gonna try this right now in the raw form you see, and see if I get this. Again, without having gone through this. Guys, let's try it. The vertex should be, first it says negative, it goes B over 2A. Well, they're asking me to go back to the original. Put replacements in. B was a -7. Twice A, looks like A is a -2. Put a comma, I'll come back to that. Don't we replace number wrong here. On the other side, that awkward formula, there goes 4. A is a -2.
Let's see.
Thank you.
C is 4. Subtract, I'll square the B, and B is -7, and I'll tell you what here, squared, all over, geez, 4 times A, 4 times a -2. Whew. Now you're talking about sad. It's gonna be sad if I crunch those out and I don't get this. Completion of the square is that's right, guys. This altogether should be negative signs floating around. So I see 3 negatives. Well, that indicates there's a negative answer. Negative times negative times negative. So it's a -7/4, 2 times 2. And looking back, oh, at least I got that. That agrees. This other one's awkward as you know what. Move here. This much, multiplied out, is a -32. That's scary. And then on the end, you got to square -7, that's 49. And all that's over a -8. You guys, the thing on top is a -81 over 8. Did I erase my negative sign with a positive?
You,
Right.
you
Oh,
missed
negative
the
over negative. It's a positive 81 over 8. Let's get 2 negatives now. And thank goodness, that agrees there. 8. Now, let me ask you this. Would you, as a student, if you saw this, and for some reason you've got to find the vertex fairly quickly, which pretty soon these word problems you have to, would you prefer to just go directly here and get it out of the way?
Yeah.
Rather than taking a sheet of paper, doing all this business, this completion of square. I just want to go directly to that formula, professor, and get it out of the way, and we're going to do that. You see those word problems, we don't have time on those word problems to do completion of the square and the word problem. So it's a shortcut. Now, some of my students may know a little bit shorter. Does anyone know maybe something else I could do to help myself out on this formula? I've been bragging on you guys. Does anyone see something else I could do that might shorten my work even less when I start using the formula?
Maybe use substitution.
No, no use substitution. No. Yeah, sounds like you guys like this. This works.
Mm-hmm.
That's part of the formula. This is the way I do it. No, I get that formula mixed up. I do this, after I find my -7/4, you know what I do? I go back to my function and plug that in. Find f of -7/4. After I find the -7/4, I go back here and put this in here. And I'll get the same answer without going through that 4AC business. It's entirely up to you, but I'm gonna do it. F of -7/4, -2, -7/4 squared, subtract 7, -7/4, plus 4. Oh boy, the fractions. Here we go, guys. -2 out front. When I square that, that's 49 over what, 16? Oh, let me make a mistake there. This in the middle is gonna be a positive 49 over 4, I guess it is, these two here, and then plus 4. Right, just crunching numbers out. I could cancel 2 into 16 in arithmetic and call this -49 over what, 8? Let's go ahead and put everything in terms of 8. Let's write everything in terms of 8, common denominator. Let's change this one to an 8 by multiplying by 2. What is that, 98? Help me out, guys. Is that 98 over 8? Multiplied by 2. And this one, if I want to change it to an 8, would be like what, 32 over 8? Is that still 4? Is that true? Now everything's over 8. I hope when I add them up, here goes. I know it's over 8. Well, this much is 49. Positive 49. And then 49 plus 32, guys, what is 49 plus 32? 81? What did we get earlier? Where is it? Where's my vertex? I got so excited about this. Did we get that? Did we get the same answer? So you could go directly back to your function, plug in directly, crunch it out, rather than using that 4AC business. It's up to you though. We'll leave that up to you. Yes?
For the vertex formula, the example you showed us, I feel like I'm gonna get confused the next time I try it. But when you had a -32 minus 49 and then -8, you took out the negatives. Did you take that out because the result is always gonna be positive, or?
Whoa, whoa, whoa.
There was a negative on top.
Are you talking about over here?
Yeah.
Okay, it's like where?
No, here.
Come on, go. Show.
I'm probably just confusing myself.
No, what we got?
Right here.
Oh, I got you. These two put together first. That's a negative. That's a -81. And you still got -8. So a negative over negative is going to change to a positive.
Okay, so you don't include that in
No,
Okay. That's why I was getting.
Positive 81 over 8.
Thank you.
Absolutely. That's what he says. Guys, we're good? Woo, what a workout. Where do you see these in word problems? You have to read the problem. Then draw a sketch of the problem. And then use this to answer the problem. Okay? Now, by the way, I think the original, since we'll close this down with this, it says to sketch it. I haven't sketched this thing yet. Have I? To get ready for your quiz next Wednesday? I haven't sketched this yet. I have all the details, I think. I haven't sketched it. So guys, when I sketch it, here we go. On the sketch itself. All this should be a recap for us. I'm going to take that vertex and plot it first. And guys, my goodness, got so much work going on here. We finally decide the vertex. Well, of course, it's right here. Here's my vertex. I'm going to go ahead and plot that point now. So I'll have it out of the way. So it's out -1 3/4, 7 over 4. 81 over 8, guys, what is it? 10 and 1/8, I guess? Something like that. Okay, so I need -1 3/4. Plot a few points here. Let's see if it will help. -3/4, -1 3/4, up here. Oh, here, 81 over 8. 10 and 1/8. And here somewhere, here's my turning point. This is my vertex. Jeez. Mark there what it looks like. 81 over 8. You see how much time it's taking this on this one problem? This could be the quiz. This could be just one problem next Wednesday. There's my turning point. Now, did we decide the parameter's going to open up or down, sideways? What's he doing? Down. Now, that means if that's my turning point, it's got to do this. It's got to do this. If it does that, it's gonna intersect, cross over the x-axis. I gotta find where. Those are called x-intercepts, before I finish this thing up. So guys, the x-intercepts, I'm gonna go back to the original. Now, believe it or not, I've had students in the past who, students are students, different ways to approach things here. Let me try to find where I am. Now, here we are. They go back to this blocked off vertex form. They said this part equal to 0 to find the x-intercepts. You could. Awkward fractions to work with, but you could take the red, said equals 0. I prefer to take
The original?
this one. No fractions in there. It's up to you. So negative 2x squared. What was it, guys? Minus 7x? Yeah, minus 7x plus 4. Set this equal to 0 and solve it. By the way, all those negative signs, I'm gonna get rid of those. Multiply through by a negative, or divide by a negative, which is allowed. And you could quickly change it into that, which I think is better. We'll factor this. You could use quadratic formula. You guys who like quadratic formula, but I think this one factors. And do not let me mess up on the factoring. I think it's a plus 4 and minus 1. Step back, look at it. I think it is. Split this up. Definitely you wind up with a 1/2 and a negative 4. That's all work for us. Is that true? So now I know what? At 1/2 and negative 4 should be x-intercept. I'm going to list them as ordered pairs. I think it looks better. Go to my grid. Oh my goodness, where am I? Negative 1 3/4, I'm out at 1/2. Here we go. Mark 1 here. And let me use a different color so I can keep all this together. Place my x-intercept in this color. This is 1/2. X-intercept. And also negative 4. I need to stretch this out. Here. And it looks like this. Guys, those are my x-intercepts. Whoa. Now the y-intercept, before I connect. This one's easier to find. You merely find f at what? 0. You go back to your function, replace all the x's by 0. It's obvious if I do here, guys, we end up with 4. I replace all the x's by 0, the first two terms drop out. You end up with 4. So 0, 4. And I'm trying to be as careful as I can here. It's in green. I don't think 4 is right here. Was it 4? That's 4. Right here. That's my y-intercept. So I got the turning point, vertex, I have the x-intercept in purple, y-intercept in green. If you connect those, you have a graph. Does the graph now look something like this, I guess? Comes up, hits that turning point, and it turns, comes down, picks those 2 points up, there's your graph. True? There's the parabola representing that quadratic.
Did you doesn't shrink it?
Oh, we're not going to do it through transformations. Oh my goodness, my goodness, my goodness. Aiden. I love what he said. If you want to do it through transformations, since we did transformations earlier, you could go back to the wait professor, I want the parent graph. Then I want to do what? Reflect it through the x-axis, then vertically stretch it by a factor of 2, and then horizontally shift it to the left, 7/4, and then vertically shift up 81/8. Aiden, if he does that, he'll end up the same place my graph is right now. You could do it through transformations. Absolutely you could. You could. Okay, is that what you're thinking of? we end up with a graph like that. Okay. Now, domain, range, all that business. By the way, since you have a quiz tonight, is there an absolute max on this function?
Yeah.
Now, usually they ask just for the y value. I think on the quiz tonight, I placed on the side there, just list the y value. What y value is acting as the absolute maximum value on this function?
81/8.
Right there. Now, what does that mean? That means if I went through class and I said this on Monday and asked all my class members to put in a different number in here and crunch it out for me, I should see no answer when I collect them bigger than 10 1/8. So if I saw an answer of 12, I'd look at the student and I'd say, no, you did your arithmetic wrong. The max is 10 1/8. The absolute max. By the way, this is also a local, this particular max. Wow, guys, now look how much time that took. That took a chunk of time, didn't it? But it had to be done. Now you say, wait, hold on. See if I'm ready. Oh boy, here we go. And then, yep, we're ready for the application problems. Now, before I jump into it, all this is beautiful. Before I race, are there lots of spaces here that you could make a mistake, a minor mistake? Yes. That's why when I usually do a quiz on this, I just have one problem. If you put the wrong number here, all of this is thrown off. You may get the x and y intercepts at the end correct, but your graph is thrown off. That's one of the mistakes will throw it off. Then all of a sudden you get your paper back, oh no, I got a 0. Which is what will happen. No, Professor, why did I get that low score? I wasn't perfect on that. It's because you, and all of us do this. We messed up back here. They threw the whole thing off. Which you could though, check it real quickly, like what, using negative b over 2a, and check and see if it agrees with what you have there. There'll be a little check on that. Okay, guys. Now, before I jump into the word problems, now I know how students are. I know how I was. Professor, I have to read a problem? I've got to read a little something that created a problem and then apply what we're doing in class to that problem? That was so hard for me. They just had a good teacher. In fact, my high school math teacher was the best teacher I ever had. Way above those college teachers. Just the way her approach was. And I thought, whoa, but now it's going to make a little bit of sense. She broke it down for me so I could understand it. With that said though, guys, I'm moving to part 4. Before I jump into it and have a student read some for us, I want to try this first. Set you up. Just a couple. Then we'll get into the word problems. Here it is. Find the extreme value of these functions. Now notice the calc, Mr. Park, they've used the word extreme quite much, I think, in calculus. Extreme, find the extreme, okay? Now guys, for us, if I use the word extreme, that means find the max or the min. So it says, just use the word extreme. Now, I have my first function, it look like this. F of x is equal to, I brought this one in, keep it fairly brief, looks like this. Is that the one we just did?
Mm-hmm.
He said, Professor, you having a bad Wednesday? You repeating yourself? Now, suppose you had not seen all this, which is beautiful, all this, and then here's my extreme, my max. They didn't see that. They just need to find it out, and I know your textbook says without graphing. The author of your textbook puts in there, without graphing, don't put a graph, without graphing, find the extreme value of this function. All it takes for you to do is, without a graph,
I have a different question.
go ahead, go ahead.
Is the absolute is the same as the extreme?
Yes. Yeah, the absolute max is like the extreme.
Mm.
That's the highest. That's the extreme. Absolute min, that's the extreme. What's a good way to find it if the book says without graphing? Or if I say without graphing on the quiz? You're gonna do what? I think we did earlier. You're gonna do this. You're gonna use the negative b over 2a. And then that 4ac minus b squared business, if you guys wanna use it. And find it right quickly, no graphing. I've already done that one. So I'm not gonna do it again. Okay, it's part B. Oh, by the way, the answer would be expressed as find the extreme value. Guys, the extreme value came out to be 81 over 8. They just want to know the y value. So the highest it goes up is 81 over 8. Now the next one, g of x. Was, what term was the problem here? I brought in this one, this one's too easy. X squared subtract 4x subtract 5. I'm not gonna sketch this. Now with this parabola, the way it looks, open up or down? Up. Open up. Leading coefficient, positive 1. Therefore, I'm looking for extreme, this time it's an extreme minimum on this graph. What is the absolute minimum? Guys, without graphing, I'm gonna still use the formula. It works for max and min. Negative b over 2a, in this case negative 4 over 2 times 1. I thought this was not too bad. Please tell me, is that a 2? Go for it.
Is that 1x?
What's that? X squared minus 4x minus 5.
There's like a line.
Yeah, it's 1.
Oh, okay.
Yeah, I'll put a 1 here.
Yeah.
Guys, is that correct? What numbers? Now, what they want though, we're not quite finished. I know what the x is. They want to know what the y is. To find the y, guys, you may use this. You guys would like this. No, find formulas, use it. I'm going to just go ahead and do it this way though. I'm going to find g of 2. I'm going to just directly replace it in my function without going through that 4ac business. If I do it correctly, and not make a mistake here, it's 4 subtract 8 subtract 5. Guys, help me out here. Is that negative 9? I did it real quick. Is that negative 9? Yes. So it is, you know this. You know the vertex is 2, comma, negative 9. I'm not going to ask you to sketch this up, but that's what you know. Now, what is my extreme value? What are they looking for an answer? This. Only. Okay, so guys, the final up here is the extreme, the absolute minimum value on this function is negative 9. No graph required. Not all that board space I had to use. I go directly to a formula. Okay? Make sense? Now. Okay. Now I need some help. On the handout, let me see your handout again, if you don't mind.
This one?
Yeah, it says applications of quadratics. Here we go. I'm gonna have a student to read, there's only 2. I'm gonna have a student to read the first one, we're gonna set it up and see how this applies to a word problem. Okay? Would you like to read?
Sure.
Okay, hang on. Make get space here to put all this. Okay, guys, here we go, Maurice. And we'll call this part 4. And these are applications.
In this part,
And it's part 5.
Is it part 4?
5.
Part 5 already?
Yeah.
Here we go. Read the first problem.
SMC is under construction.
Ooh, stop right there. Yeah, are they ever? In fact, with all these new buildings and not this new complex. You guys should have been here before this was usable. It was a mess. It was all types of construction taking place. Tell me more.
Workers have 1,200 feet of fencing to enclose a rectangular space that borders on Pico Boulevard. If no fencing is needed for the side along Pico, what is the largest area that can be enclosed?
Now, they're telling me, she's telling me, at SMC, for some reason, they want to enclose a particular piece of, the property here along Pico. You know where Pico is out there. And since Pico is there, no fencing needed there. Pico's the boundary already. No fencing needed on that side where Pico is. But the other three sides have to be fenced in. And the question comes down to, read that last part to me one more time.
What is the largest area that can be enclosed?
I heard the word largest. For us, maximum. For us, make it B over 2A. That's all it comes down to. As soon as I see that keyword largest, they're asking about the max. Now, I said, Professor, that's nice, give me the function. That's the problem. We have to create the function. I'm not gonna write the f of x for you. You gotta create the function for you, for us, and then you gotta use that function and come up with, the way we've done some of these today, you gotta use negative b over 2a, 4ac minus b squared over 4a, that business, and answer the question. I don't have the function. Read that to me one more time and I'll illustrate the best I can.
The whole,
Yeah, start from the very beginning.
Okay. SMC is under construction. Workers have 1,200 feet of fencing to enclose a rectangular space that borders on Pico.
Now, stop right there. A rectangular space, here goes. Visual here. And guys, I'm gonna show the side that represents Pico. I'm gonna show that in a different color, because I need not worry about fencing that in, or using a fence. This will represent Pico. Now, they want to fence in that. But they want to fence in on 3 sides. Don't use the street itself, Pico. Okay, tell me more now.
If no fencing is needed for the side along Pico, what is the largest area that can be enclosed?
Okay. They've already gone to Home Depot, picked up their supplies. How much fencing do they need?
They have 1,200 feet of fencing.
They got 1,200 feet of fencing to fence in those 3 sides. So if 1,200, just divide them evenly, have all those sides to have the same length. 3 goes into what, 1,200, 400? So each side's 400, and we're finished. Did they say do that?
No.
No. How many different ways could they take 1,200 feet of fencing and use it? No, many ways. So they're saying, no, you're not gonna divide it up evenly or divide by 3. So what I'm gonna do is, I've got 1,200, is that true?
Yes.
I'm gonna do this, which makes sense from geometry. Guys, I'm gonna call this x, this x, for the width. Is that okay? Okay, now, what's left over? Or whatever is left over of that 1,200, that represents the side down here, the longer side in this case looks like. That's opposite or parallel to Pico. What's left over? How could you represent what's left over of the 1,200?
1,200 minus 2x.
Thank you. 1,200. Absolutely. Subtract the 2x. You got x and x, that's 2x. So the remaining, and to find the remaining 1,200, subtract that, subtract these two, is 2x. And that's 1,200 subtract 2x is the other side. By the way, at this point, if I should add all those up in the red, does that take me back to 1,200? When the x is canceled?
Yes. Yeah.
If I add up everything in red, I'm right back to 1,200. That's what they had. They had originally 1,200. I split it up like this. Now, they want us to, I think, find the largest,
The area. The
oh,
largest
area. Guys, to find the area of a rectangle, we know how to do that. Most students think of it as length times width, or base times height. But I'm not seeing this. Either formula, length times width, says multiply these two together. Base times height, multiply these two together. So guys, in this case, my area is going to be equal to, at this point, x times 1,200 subtract 2x. That's base times height or length times width. Make sure we agree. We agree? We got awfully quiet. As soon as I mentioned word problems, I thought, ooh, professor. Are we okay? Length times width? Now, if I multiply this out, by the way, guys, notice all this is in terms of x. So we'll call this a of x. Make it look like more like an f of x, a function. A of x is equal to, distributive property gives me this, and this. 1,200x minus 2x squared. That's my area function. Now there's my function. I now have a function to work with. That's like an f of x. At least I got something to work with. Now, tell me from just a few seconds ago, they want what of this function? They use the word largest. We want
Maximum.
the maximum. Now they're going to go through and complete the square of that mess up there? No. Am I going to use the shortcut? Yes. And what am I going to do to get a start here? I'm going to say I need the vertex. By the way, guys, this is turned around. Is the leading coefficient, if I flip the terms around, is it a negative?
Yeah.
And if it's negative, should the parameter be opening down?
Yeah.
And if it opens down, are we talking about a max?
Yes.
So we're getting to max. Now, do you get it? And we use negative b over 2a. Now be careful, it's turned around up here. That's we had negative b in this case is 1,200. 2 times a is 2 times negative 2. My number's in. Looks like we end up with a positive answer. Looks like it's 1,200 over 4. What is that, 300?
300.
I think. You guys agree?
Yeah.
Now, what have I just discovered?
The x.
The x, which was this. So this must be 300 feet. I should put here feet. Oh, that's 1,200. Now, can someone tell me what's left for the other side? This side. 300, 300, that's 600. We had all together what, 1,200? So the other side must have a length of 600. Add all these up, you'll get 1,200 feet. 300, 600, 300. Yes or no? Whew. Now, I'm using negative b over 2a. We got that. Now, I'm trying to find the vertex, which won't give me the answer I'm looking for here, guys. The vertex at this point is 300 is the x. I just found it, maybe it's negative b over 2a. Would you guys like to go ahead and use the 4ac minus b squared to find the other coordinate? Or you want to go and plug in 300 into my function?
Plug in.
I think either way it's going to be awkward, because I got a square of 300. Is that true?
Yeah.
It's up to you though. 4ac minus b squared over 4a, or just find the function. So guys, let's try to find a of 300. And we'll go back to my function and plug it in. Now, I need some space up here. My function at 300, easily done. Well, not too easily. 1,200. Now someone's going to really have to help me out here. I see some big numbers.
36.
Oh my goodness.
30,
Is it
36
That's the way it looks.
minus.
Is it 300?
Does anyone know the final answer?
18,000 square feet.
Ooh, 18,000? Sounds reasonable. Did you go directly through and multiply all that mess out?
Yes.
Okay. Now, see, one way you could do it, it's up to you, you could just directly do it, say, I'll crunch these numbers, professor, they're large, I'll crunch those numbers. You could do this. which may help a little bit. I do see, in these two terms, I could take out a common factor, maybe 300,
Yeah.
at least 300. And that would leave me 1,200, subtract 2 times 300. Okay, I took out 300, I'm stepping back and looking at it, make sure. You guys agree with that?
Mm-hmm.
Took out common factors, which may help. Let's do an arithmetic. Now inside there is 1,200 subtract 600. Is it inside there? 1,200 subtract 600,
Yeah.
which is what, 600?
Yeah.
And then I multiply those two together, and I think the answer is 18,000.
Yeah.
Being clever. 300 times 600, I think it is 18,000, isn't it? Or is it 180,000?
I think it's
Is it 180,000? Oh, hold
Because
on.
what's
Whoa,
1,200
whoa, whoa, hold
times
on. This is 3 times 10 squared. This is 6 times 10 squared. The two guys? This was something?
Yeah.
Right. This much is,
18.
what, 18 times 10 to the 4th. That's just me doing some work there. I think it is 180,000. Is it 180,000?
I
not
misspoke.
18.
I misspoke. That's what I got.
Right, you told me 18.
My bad.
Okay, 180, right?
Mm-hmm.
So 180,000, oh, Jesus. Where am I down here? Right here. 180,000 square feet. Jeez. Now, before I ask her to give me the next problem, which I think is gonna be a little bit easier, we'll see if it is. Tell me on the very end, what were they asking me to answer before I leave this?
what is the largest area that can be enclosed?
Now, I've done a lot of work up here. What would you place on the blank if they say just place the largest area? What up here in all this work represents the largest, the maximum area?
18 times 10 to the 4.
That's the Y value. It took more for us to get there, but they just want to know what is eventually that Y value. If all the arithmetic's done correctly, it's 180,000 square feet for the area. Okay? So that's, I hope would make a little sense here. Now please tell me, is the next one something being tossed in the air?
Yeah,
Oh, that was easier.
the philosophy.
Oh, that was easier. I think if I remembered when I prepared this for you guys, did I give the formula to you?
Yeah.
Yes. This one I had to create the formula. Okay, read that to me.
A stone is thrown upward from the top of a building. Its height in feet above the ground after t seconds is given by h of t equals minus 16t squared plus 48t plus 32. What is the maximum height reached by the stone?
Now, the students love this one. They're saying, Professor, if you test us on a word problem involving quadratics, please give me this one. Please give me this one. Okay, go back and read to me one more time.
A stone is thrown upward from the top of a building.
Okay, hang on. Let's do this. Let's say, get a visual to work with. It's your top of the building. And you're going to toss, for some reason, a stone from the top. We're hoping, based on this chapter, we're hoping when you toss it, it goes up, eventually turns, and comes back and hits the ground. That's the path we're hoping for chapter 2. What type of a path would that be described as? It's a parabola.
Mm-hmm.
It's a parabola. Now tell me more.
What is the maximum height reached by the stone?
Stop right there. They're asking me to find this right here, which is the vertex, and then I'll answer her maximum height. How high does it go for a max? And I think I gave, or did I give the formula to you? H of t was it, height? H of t was, remind me?
Negative 16 t squared plus 48 t plus 32.
Got it. There's your formula. Now please tell me, quickly, I'm not gonna complete the square on that. What's a quick way to try to come up with the answers that they want on this tossing a stone in the air from a building? What am I gonna do?
Minus b over
Negative b over 2a. If I use negative b over 2a, now notice guys, this one's in terms of t time. You're using t for time. So t is just like x. But by formula, it's still this. Negative b over 2a. I love negative b over 2a. No completion of the square. Put in my numbers.
Negative 40.
Negative, what is that, 48?
48 over 32.
I got you. Twice negative 16. And if I put all that in correctly, it's going to be a positive for sure. That's 48 over 32. Which I think reduces down by 16 into 3 halves. Now I gotta be careful. That's what I found. That's t. What's t representing? I found the time.
Time.
I found the time. But they want to know what is the height. I haven't found that yet, but at least I know the time. So it's going to take 1.5 seconds after you release that stone for it to reach that maximum height. 1.5 seconds to go from the top up to the maximum height. They want to know what is that maximum height that reaches from the ground. Here's the maximum height. They want to know what that is from the ground. Now what do I need to do? I need to use 4ac minus b squared over 4a, or, here we go, go back to my function and find h of what?
H of
3 halves. Just plug in 3 halves. Now again, you guys like 4ac business? Go for it. Okay, go back, guys. Be careful. It's negative 16. I'll put it over here and then out of your way here. Negative 16. We'll put 3 halves in here. 3n squared plus 48. 3 halves plus 32. Now, do not let me mess up here. That's 9 over 4. In the middle, I could cancel 2 into 48, that's 24, I think. And 3 times 24 is 72, I'm just doing math, plus 32. Going back to the front, first term, cancel, get a 4. Guys, I think it's a negative 36. Plus 72, plus 32. Add those numbers up, please tell me, is that 68? I may be wrong, can someone do it? Is that 68? Can you add all those numbers up?
Yeah.
We have to do a field trip and go to that school across the street one day. That's what I should call some of those teachers up across the street so we eat out. Make a field trip. Let's see what those little 4th graders are doing over there. Is that true, guys? That's 68? Okay, now, if you don't mind, read that to me one more time and let's see if we're finished with it. Read that entire thing.
Okay. A stone is thrown upward from the top of a building. Its height in feet above the ground after t seconds is given by h t equals negative 16 t squared plus 48 t plus 32.
Now stop right there. Now have your picture. Can anyone, and I always have students who know this, but reflect back. If anyone's taking a physics course somewhere, maybe a high school physics, or it might be trying a physics course here, you might know, even though I will give these numbers to you like I did on the handout, you might know where these numbers came from. I'm not quite sure to do it. Does anyone know from a little physics where those numbers came from, even though for us they will be given? Does anyone have an idea why negative 16 in the real world? What's it have to do with the ball or a stone being tossed up in the air?
Acceleration.
Thank you, gravity. Has to do with that gravity constant for acceleration. Does anyone know without physics maybe maybe what that 32 represents in terms of the stone being thrown up into the air. Velocity. And guess what the last term represents? Guess what the last term represents? Tell me, how tall was this building? Did they say? Oh, they didn't say. Guess what it is? It's 32 feet high. If I knew what those numbers represented. You don't have to worry about that, I'll give those numbers to you. That's one less worry for you, because that's where those numbers came from. Now finish reading that last part.
Okay, so the first question was, what is the maximum height reached by the stone?
Hold on, guys, this is the answer to the first one. It goes for a maximum, right here, 68 feet above the ground. Now, how many seconds is it gonna take it to go up to that height from the toss?
3.5.
3.5 seconds, 1.5
So
seconds,
yeah, at 3.5.
right?
Yeah,
And that's all they asked.
no, there's more questions.
Oh, there's more.
Yeah,
What?
the second one is, how many seconds does it take to reach this height?
Okay, that's 1.5 seconds, we got that out of the way.
Yeah.
The 1.5 seconds to reach after you release the stone, it's gonna take 1.5 seconds for it to reach that maximum height, which is right here, and that maximum height is 68 feet above the ground. Now, the next one, and then we're gonna take a break. What else?
The last one is, how many seconds will it take for the stone to reach the ground?
Eventually, it's gonna hit the ground. After it's tossed up, it's going to come down and hit the ground. They didn't say at what velocity does it hit the ground. They want to know how many seconds from release will it take for that stone to hit the ground. Can someone be clever and tell me, what should I do with what was given to me, which is this? To answer, how many seconds will it take for it to hit the ground, Sophia? No, what were you thinking?
I was thinking that we take the, from that like short part from how much it took to reach the height, and then we add it to, from the building to the wall.
Okay, now I know it takes 1.5 seconds for it to do this. Right? It takes 1.5 seconds for it to just go from release to the max. But there's more time here. Does anyone have an idea? Now come on. We're gonna close down and take a break. What would you do to find the amount of time it takes for it from release until it hits the ground? How many seconds is that? Go for it.
When it's 0,
Whoa. If you hit the ground level, you're at 0.
yeah, below the level is 0.
The height is 0. Please tell me, if you hit the ground, is the height gone? There's no height. It's the height 0. So she says, Professor, write it like this. Common sense. When it hits the ground, there's no height. Height is 0. That's like you asking, or I ask you to find x-intercepts. Now, how you gonna do this? You gotta solve this quadratic. You guys wanna divide by, I gotta solve it. I know, getting stressed out, I hope it factors. I don't wanna use quadratic formula, but I'm gonna take a break here. I could divide everything by -16, and that would make it look a little better. Darn it. I can look at that. Guys, that's division by -16 to make it look a little better, and it's still not gonna factor. I don't think it factors. Here we go. Okay, here we go. The time for it to hit the ground will be equal to, by formula, 3, negative b, plus minus square root. B squared is 9. Subtract 4 times a, which is 1. Negative 2, which is c, all over 2. Darn it. 3 plus minus square root. Don't let me have anything wrong here, guys. It's 9 plus 8. Is it? It's some strange answer. 17. All over 2. Separated. 3 plus radical 17 over 2. And another possibility would be 3 minus square root 17 over 2. Now we're talking about time. That's separated. I think I have to reject one of those. Yeah, I can't have a negative time. So this one has to be rejected. Square root 17, guys, is 4 point something. So this would result in a negative, that's out. This, you can approximate if you wish. I know radical 17 is 4 point something. 3 plus that's 7 point something. And 7 point something divided by 2 probably is 3 point something. So it's going to take 3 point something seconds for it to hit the ground. Woo! Yes.
How would you, get rid of the box?
Right here, because this is going to result, we're talking about time here. So right here, that's going to be 3 subtract on this one, 4 point something. Okay, this is going to result in a negative. And I cannot have a negative answer for time. Katie, that's what you're asking about. Guys, anything else? I've worked you hard already. You have a quiz later on. Are you going to have the energy to do it? Gee, Ramsey, it does not slow down. I wish I had you guys 5 days a week. Wouldn't that be nice to meet Ramsey 5 days a week? I'd love it. Right? Maybe for 1 hour. Have a class like that, just 1 hour or 1 hour and a half. That'd be nice. Hayden was coming here smiling every day. Oh, we get to see Ramsey again. Yeah. Katie said, oh, today's Thursday, but it's Ramsey's here. That'd be nice, Monday through Friday. Okay, so guys, we're okay here. Beautiful. You got a nice 10-minute break, so I'll see you in 10 minutes.